here. All right, hello everyone. Welcome to OpenHour. I'm really excited for this week's topic. This month. So we're talking a little bit of water everywhere, and monitoring tools, techniques, and strategies. So we have been doing OpenHour for a few years now, and kind of realized just recently that water was one of the first topics that we had done, and we hadn't revisited it for a long time. So we're hoping to sort of recircle around some exciting things that are coming up around water, and share some good conversations, and use this as a jump off point to circle back around water on public lab and everywhere else. So I'll just go through. I don't know if everyone sees the lineup the same way I see, but I'll go left to right on my screen in terms of who's showing up, to do a quick intro of who you are and where you're calling in from. And we'll get started there. So Liz, you're on my top left corner.
Wow, how about that? The bribes worked. I'm Liz. I'm Stevie's coworker at Public Lab, and I'm calling in from Brooklyn. And there's really a lot of water groups up here, mostly concerned with getting the old industrial canals and kind of tidal estuaries around New York to be swimmable and fishable again. Yeah.
Great. I'm actually next on my lineup. So I'm Stevie Lewis, and I'm calling in from a phone booth in New Orleans. They exist still. Yeah, I guess one of the things that's interesting for me recently is we've been talking a lot about stormwater and sort of stormwater monitoring strategies. So just in New Orleans, it's kind of something that we've been interested in for a while. Julie.
Awesome. Had to unmute myself. Hi, I'm Julie Bastine. I direct the Alliance for Aquatic Resource Monitoring, or ALARM, which is housed at Dickinson College in Carlisle, Pennsylvania. And I'll wear a couple of hats. We're a 31-year-old aquatic citizen science organization. So we're involved in a lot of state, regional initiatives. And I'm also the second volunteer monitoring rep to the National Water Quality Monitoring Council.
Great, thanks. Gwen, are you able to go off mute?
Hi, can you hear me okay?
Yeah.
Hi, I'm Gwen Schroeder. I'm a filmmaker and a former resident of a community in southern Texas, looking to do some monitoring in a petrochemical area, specifically in the Brazos River, where they do a lot of dumping of waste.
Great, thanks, Gwen. Patrick.
Hi, can you guys hear me?
Yeah.
All right, yeah, my name's Patrick. I am a citizen science volunteer, I guess I'd say. I've been involved in environmental education and local environmental enforcement before, and I've volunteered a lot around the Riffle data logger.
And where are you calling in from?
Oh, I'm calling in from Rockville, Maryland.
Great. Amanda, are you there?
Yep, can you hear me?
Yes.
Okay, my name's Amanda, and I work for the National Institute for Water and Atmosphere in New Zealand. And so it's 2 in the afternoon here, the day after you guys. And we're trying to develop a national citizen science strategy. And so I'm working as a postdoc on this project. And so
Alexa, trigger fans.
So I'm looking forward to some low-cost monitoring technology that I can introduce to New Zealand.
Great, thanks. Emily.
Yes. Can you hear me?
Yes, I can hear you.
Okay, good.
Great.
Okay, so I teach journalism at West Virginia University in Morgantown, West Virginia, and we did a sensor journalism project last year. We used the Riffle sensor to look at water quality around Morgantown, West Virginia, and we had some success with it. We actually got journalism students to get it to work. We also had some failures, learned that the Gatorade bottle that we housed it in really could only be deployed once. And we also learned that we needed to work with experts closely. So yeah, I'm excited to try to help anyone else who wants to embark on a similar sensor journalism project.
Great, thanks, Emily. I have next is Zen Girl.
Yeah, can you hear me?
Yeah.
So I'm from Philadelphia. I'm a maker. My only touching with water monitors has been with a project I did with Stroud Water Research, working with their new board. So that's as far as I've gone, and I'm really interested to hear everybody else's comments tonight.
Great, thank you. Dan, you're on mute. Are you able to unmute?
Yes, I can unmute. I'm Dan. I'm from Picayune, Mississippi, and I'm just a tinkerer interested in technology and stuff, so I'm just kind of observing.
Great, thanks. Toby.
Hey, can you hear me?
Yes.
Awesome. Hi, everyone. I'm calling from Madison, Wisconsin. I'm a researcher at the University of Wisconsin here. And I'm looking at food security and agricultural issues. And I'm a total newbie to this space, but I'm really excited about using open hardware approaches, particularly around groundwater monitoring in rural Africa.
Great, thanks, Toby. Elizabeth?
Hi, I'm Elizabeth. I'm right next door to Patrick in Washington, D.C. And I am headed to China in April on the National Committee for U.S.-China Relations to work with Green Hunan, which is an organization which has over 300 water keepers. I see some heads nodding. And one aspect of this workshop is sharing the lovely, things of citizen science and public labs, but also they want to learn a bit more about low-cost sensors for water quality monitoring and improve their methods. So this was an excellent opportunity to learn about what's going on in this space.
Great, thank you. Chris?
Hi, yeah, I'm an economist. I just recently moved to Los Angeles from Washington, D.C., or first from Washington, D.C., and then through Berlin. And I'm experimenting with new approaches to get citizens more involved in decision making, especially for climate adaptation and around water infrastructure.
Great, thank you. Dave B, have I done this yet? People are moving now. Are you there?
Yeah, I'm here. Can you hear me?
Yes.
Cool. Well, I'm Dave from Chicago, and I work at the Peggy Nature Museum, working mostly with high school students.
Dave, you're
where they design their own kind of systems going on.
It sounds like we're struggling a little bit with your connection, Dave. But I think I know who you are. Are you David Phillip from Chicago, working from the museum? Okay, great. If your connection comes better, just say something and we'll test it out with you. Otto, AOTTO.
Hi, I don't know, can you hear me okay?
Yes.
Oh, great. So I'm Andy Otto, Santa Fe, New Mexico, Santa Fe Watershed Association, and we have an Adopt the River program and haven't been doing monitoring yet with our volunteers, so I'm here to learn.
Great. Thanks for joining.
Yes.
And then I have someone calling in from a telephone as well. Are you available to speak?
Yeah. This is Renata. I'm calling from New Orleans, and I'm more listening in, but we are working against the bio-rich pipeline, and that will impact water. So I'm just listening in.
Great. Thanks, Renata. All right, so we have so many people here from so many different places, really exciting. I normally for Open Hour, I do just like to open the floor for anyone who is interested in starting a question or conversation on the topic. But if we're looking for some guidance, I have some questions we can use as well. So if anyone has a burning question on the topic, please feel free to speak up. Oh, I see someone, Chris, you're speaking, but it looks like you're on mute.
Yeah, that works. Yeah, so I seen that like you guys have this tree kit, right, for doing a lot of sort of citizen science around for checking out trees, monitoring growth, all these things. Do you know of any implementation of that going on in Los Angeles? Because we have a lot of sort of citizen, like a lot of volunteer days, a lot of tree care stuff, but the citizen science element I haven't necessarily seen yet.
Liz, you're on mute.
Yes, hey. Tree Kit is a project that I ran with another collaborator. It's not actually part of Public Lab, but I'm happy to answer questions about it.
Okay.
We're all friends.
Okay.
There are a lot of tree stewardship groups in Los Angeles.
Yeah.
In fact, really, Tree Kit can trace its lineage back from New York back to San Francisco, back to Los Angeles, if we were to tell a really long story. But what I'd like to do, could you just send me a message in the chat, and I will follow up with you on email right now and see if we can put you in touch with anyone who's doing like a measured tree inventory in LA.
Okay. Okay, that'd be great.
Great.
So I have a question for those of us who are out there. I'm really excited about sharing this space with such a diversity of people who have worked on various aspects of water quality monitoring, from really the beginnings of working in citizen science and getting people sort of thinking a little bit about the watershed and big picture, all the way down now to thinking about some of the electronics and tools and open source technologies that can go into that. So I was wondering a little bit to just sort of bring these two things together, if we can have a conversation about sort of if people what we've sort of found working with the open source world, as well as like on the community level in terms of trying to get some people to monitor in the backyards of what's actually going on in our streams. So where is the intersection between these grassroots organizations doing water quality monitoring work and some of the new technologies that we have coming out? I'll call on you. Emily. So I was wondering, can you speak a little bit to some of the experiences your group had and some of the things that you were struggling with and successes that you had? Oh, I think you're on mute.
Yeah, so I didn't work with, we didn't work with a watershed group. We were a class of journalism students, and there were certainly students who were not at all comfortable with the technology, and so it took them a while to get used to that. Let's see, I was making notes while you were talking. So you were wondering how... Can you rephrase your question for me again?
I'm wondering about the intersection between some of the, there's a lot of really great technologies and methods that people have used on water quality monitoring for a long time. And there's been a recent spurt in some of the new sensor technology. And I'm wondering a little bit about the intersection and crossover between the two.
Well, so we worked with John Keefe, who I'm sure a lot of people in this group are familiar with. He's a data journalist from WNYC. And so we worked with him, and he is really the intersection, I feel like, between the technology and bringing it really to the people. And you know, so I'm speaking from a journalist perspective here of using this technology, which is very similar, I would think, to, you know, the community group's perspective. You know, we are citizen scientists, journalists using these devices. So I think that having John Keefe there to help us was wonderful, because he knows as a journalist, you know, the information that we're looking for, the questions that we're going to be asking, what we need in terms of developing a story, but yet he also had a really good command of the technology. So he was a wonderful resource for us for this project. I think as a journalist, because I was a journalist, you know, for 10 years before I started teaching journalism, I did not have experience working hands-on with this kinds of technology, and, you know, even with coding. And a lot of our students don't either, although they're getting that experience more and more because we are, you know, pushing for innovation in our curriculum. And so this was one way we were doing it. But I think that, you know, it really takes somebody who has an understanding from both of these worlds, you know, the citizens who maybe aren't comfortable with the technology, but they know the information that they need to get, they know the questions that they have, and then somebody who is savvy with the technology, and who can marry the two. And so certainly we leaned on him a lot, and on Don Blair, who helped us out as well with this project. And I mentioned too in my introduction that one thing that we learned about the process for doing censor journalism, which again, I'm going to talk about censor journalism, but I think that you could insert, you know, citizen science anytime with censor journalism, because that's what we were doing with citizen science. But you know, one thing that I found that was really important was involving experts in water quality. And we're at a university. We have researchers who specialize in water quality research. And so we went and talked to them and had them actually come to the class and talk to our class about water quality issues right from the start. And they were there with us when we had questions, not just about the technology, because they weren't necessarily familiar with the sensor that we used, but if we had just questions about the science of you know, testing water quality, then they were our experts on hand. So that was very helpful too. And right now I'm actually doing another censor journalism project that's looking at air quality. And again, we've taken that same approach. We found experts at the university who study air quality, and they've come to the class and they've given lectures, and they've talked to me personally about the science around testing for air quality. So I think that going into this as a citizen scientist or as a journalist with not a lot of the technology experience, you have to surround yourself with people who are familiar with it and lean on them, but then also get your hands dirty and get in there and use it too, which we did. It was a lot of fun.
Great, thanks. I see there's a question in the queue here on the chat on the right. And Otto, do you want to speak up and ask your question?
Yes. Excuse me.
No, go
I
for
was
it.
going to ask, what were you monitoring for? Was it, you know, dissolved oxygen, turbidity, what pH?
Conductivity levels. We were looking at conductivity levels.
Okay.
Mm-hmm.
Gotcha.
Right. So so we were, the whole time we were doing this project, you know, we definitely understood that we weren't going to get results that were going to tell us exactly what might be wrong with the water quality, but that if high conductivity levels were found, then something was probably going on here. And so it was really just a clue to look further, you know, to look a little deeper in a particular area. Don Blair actually came to West Virginia University last spring. We did a workshop for citizen groups on using sensors. And he gave a presentation, and I loved what he said. He said, you can really use this to tell, does your river have a fever? And I thought that that was a really great analogy for how you could use these sensors.
Gotcha. Thank you.
Mm-hmm.
Patrick.
Hey, I'd like to talk a little bit about the intersection of citizen science and government too, if that would be interesting.
Sure.
I was very lucky to have an internship last year with a local government, so I only have like one very small snapshot of how things might work out, but I can definitely resonate with the fact that the people using this technology right now are not the most tech savvy and don't really have the time to be tech savvy. The people I worked with were experts at water quality and about policy, but they didn't have the resources to actually measure the streams, which to me was insane. The fact that you had a government that like monitoring was really, really low down on its priorities just because it was hard to do well. And something like, does your stream have a fever, would have been incredibly useful for them, because they'd be able to go and give more resources and find out like what was happening in that area. But that just wasn't even on their radar to be able to monitor the streams. So to me, this is a really big area of growth. We did have a citizen science person, like an outreach person working in the department. And she would tell me like, hey, our citizen science that we do is definitely like 99% citizen and like 1% science. Like those are my words, but the science that they got was really more to engage the community and teach them about watersheds. And the data that was gathered was theoretically used and like pooled with other data, but it really wasn't that useful. So that added to the fact that I think going along with the experts thing, we didn't really have the chance to bring in experts, but in the Rockville and DC area, there really are a lot of untapped experts here. There's community colleges nearby. There's all kinds of government agencies, like the USGS does stream monitoring in the area, but they don't really have a network for sharing that data with the people that are right nearby. So I think there could be like one thing that people could really work on is connecting the resources that are already existing in an area and have them talk to each other more. And I think one thing that people can do is, like where I live anyway, there was a environmental commission of citizens that could go in, and there were like regularly held meetings with the local government where people could bring their ideas and volunteer as a citizen, but like with the support of the government. And just the fact that like nobody ever came to those meetings, like they were boring and nobody ever really went, but that was an opportunity for like citizens to say, hey, what if we brought this technology? What if we did this? So I think that resource does exist, like citizen like listening sessions and things like that in government is something that can happen.
Julie, I see you've dropped a resource in here in the chat. Do you want to talk about it?
Yeah, sure. And also maybe broaden the picture a little bit. You know, I think that citizen science has gained a lot of traction in the past decade, but it's also important to remember the fact that in the aquatic citizen science movement or volunteer monitoring in the United States, we have a really long and robust history. So some of the earliest lake monitoring programs date back to the late 50s. And today there's over 1,700 programs throughout the United States monitoring different water bodies. And in 48 out of 50 states, there are active volunteer monitoring programs. And I think one of the things that the volunteer monitoring program programs have done well over the years is making sure that you're matching the quality of data being collected with your intended end use. So one of the tools that I dropped into the chat box is a version of a study design process. And this is a tool that was originally developed by River Network. And the idea is before you begin an aquatic citizen science project, you think through all the necessary steps to make sure that you're identifying the questions that you're looking to answer and that you're identifying right from the get-go the quality of data you need for your intended use. So if you're looking for education, you can get away with certain techniques. If you're looking to use those data for your state's integrated reports, you're going to need to use different techniques as well. And when you look at the nation and you look at some of the different ways that volunteer monitoring is set up, there are 18 states in the nation that have done a really good job of matching and developing a tiered system and framework for the quality of data needed for different data uses. And so I think that that's something that is important to pay attention to. I think volunteer monitoring has had a lot of success with being able to use data in a lot of different ways, from identifying those hot spots that need best management practices to mitigate an issue, to also raising red flags for agencies to go in and investigate something, to also having data used to inform the state required integrated reports. So I think that it's important to think through those steps. And another strength that I've heard about aquatic citizen science from folks that are studying diverse citizen science fields is we have this attention to quality assurance. And I think that that's something else to keep in mind as you're developing your program and you're playing with different sensors and playing with different techniques, that you're building in assurances into your program so that you can document that your data are of known quality. And I think that's something that is emerging with the sensor work. We have the chance at Alarm to work with Stroud Water Research Center, and I didn't see Shannon in on the call today, who's developed the Mayfly. And they have a great accessible data board for using those techniques, but they even talk about the fact that if you want to use the data for different uses, you have to invest in different amounts for the probes that you attach to that. And so again, I just think thinking through all those steps and what we use in volunteer monitoring with the study design process and thinking through how you're going to use the data and the quality assurance techniques are really important.
Zen Girl, our friend of Shannon, I see you there. Do you want to talk a little bit about the Mayfly or respond? I saw you with your hand earlier.
I guess I could say that and actually I shouldn't say that I was on the Mayfly. I was on the precursor to Mayfly, so I have to correct myself. But basically what happened is one of the main boards that we were using ended up being discontinued, as some hardware is. And so that was yet another impetus for Shannon to invent the entire board from scratch and just go with, a board design that would work. So, so I can definitely speak to some challenges just working with, just outdoor equipment, things like, Liz, you had mentioned like the box, the incredible box that the thing is in. It's like making sure that something is weatherproof was definitely like one of the prime issues, and learning how even when soldering, I'm used to soldering parts, but there's like a special gel that you put on those solder joints as well to protect them from humidity. There's like those little tiny issues that are just little nice things to know about. Things like trees do grow in over time. So if you've installed your monitor and you're using a solar cell, that eventually those trees may block your solar cell from recharging batteries. So those were some of the issues we had. I'd say the other main one was the fact that streams are usually located in deep ravines or valleys, and they often can't get signals. So even though my board setup would have had the capability to get that data to a spreadsheet somewhere, we could not get the signal. It was very intermittent. So at this point, I know that we'll still be having to either put like a third signal location in there, sort of like acting as the middleman between posts, or just setting up some sort of cell signal. So those were some of the challenges we faced. The new board is going to be pretty spectacular, and I'm getting ready to change out the board that I have for the new board, and hopefully we'll help write a more detailed tutorial for them. And I don't work for Stroud, I should say. I'm a fan, though. I'm a total fan.
Yeah. Cool. Great. Julie, you brought up something interesting that I've seen a little bit, but I was wondering if you could give a basic rundown of the tiered approach that you mentioned that some states have implemented.
Sure. I've done this research for two reasons. One, through my role in the council, and two, we're part of Alarm's a part of a Chesapeake Bay monitoring initiative, and it's the first time where we've had to take 6 states and 6 very different models of engaging with volunteer monitoring and trying to integrate that. And some of the states within the watershed have a tiered approach and guidance of how you match the quality of data collected with an intended use, and some didn't. And so one of the building blocks of our Chesapeake project was to establish a tiered framework for how we were going to integrate volunteer collected data into the federal Chesapeake Bay program. So when you look across the country, there's a lot of different ways. I mean, when you look across the country, there's some pretty fantastic state-run programs. And so whether it's being run by a state agency or whether it's being run by a service provider entity that's providing technical and programmatic support to watershed groups, you often see an approach of trying to match the quality of data that a volunteer can collect with an intended use. And so some states take an A through D approach, some take a tier 1 through 3 approach, etc. So in Virginia, and then in Pennsylvania and West Virginia, and then so we've adopted this for the Chesapeake. Tier 1 for us is education, but there's still education and basic screening. Tier 2 is pollution hotspotting and data that can be used for report cards and things like that. Tier 3 are data that can be used to help inform whether or not the Chesapeake Bay is on track for meeting its policy regulated total maximum daily load. And so with each different tier, you have different techniques that produce a certain quality of data, and then you also have different quality assurance measures in place to make sure that you're getting the best possible data. So I like to use nitrogen as an example. So nitrate nitrogen is commonly used in water monitoring for folks that are interested in stream monitoring because of agricultural runoff. We're interested in looking at that. If you're looking to do youth-based education, you're trying to raise awareness about nitrates in the stream, I'm going to recommend to you to use a zinc reduction nitrate nitrogen kit. It's a safe test to use. You get a ballpark of what the nutrients are in the stream, but you're using, you know, a safe technique that doesn't require doing all these quality assurance techniques. If you're a community member that is looking to document nitrate nitrogen as a way of flagging it for a policy initiative or something like that, you want to align your methods as much as possible with standard methods. So there are techniques out there that are cadmium reduction. That's what you're going to find in a certified lab. And volunteers can do this as well, where you have a color wheel or a color metric probe or what have you, and you're using cadmium reduction, you're washing your glassware in accordance with standard methods, and that falls into a tier 2 within our Chesapeake approach and a lot of common models. And then tier 3, if you actually want those data to be directly used by a state for their integrated reports, that's an example where a volunteer will collect a sample and deliver it to a certified lab for a certified lab analysis, and then that can automatically be folded into state regulation and agency oversight. Does that help?
Yeah, that's great. Thank you.
Sorry, can I just ask a question about the tiers?
Please, anyone, the floor is open. Unmute and ask away, all things.
I thought that was really helpful to hear about the different tiers. My question is, did you, just because I'm not sure about this, did you establish the tiers like your group, or are these like nationwide or international tiers that have been established?
Yeah, so it'd be really great if there were national standards for that, but the project that we're a part of for the Chesapeake Bay, it's the first time it's a project where volunteer collected data are being integrated into a federal program, and so this is the first of its kind. So that's one of the reasons why when we were developing the building blocks for this, we took a lot of time to research. When you look across the nation, like I said earlier, we only found 18 states that had it available on the website, a tiered approach. So it could mean that there are other states with tiered approach, but we weren't able to find it. And each state had a slightly different way of approaching the tiers, but essentially it fell within those 3 or 4 main categories. So, I think one of the things that we've been talking about at the National Water Quality Monitoring Council is, thinking through what are some of these guidance and some standard measures that we might be able to suggest to the national volunteer monitoring community as a whole. And I think that, building off of the tiered framework and these tiered designations is something to bring up. But I also, I think sometimes when it comes to state data use, a volunteer can be really hung up on, oh, I want my data to specifically only be used by the state. And for us, that's not that's not our end game. Like, we see additional data use as icing on the cake, but we want to make sure that our communities who are designing their monitoring programs and implementing it, that they're using those data directly within their watersheds as well, and that they have that local data use as well. And I think someone mentioned the challenges around the fact that with the aquatic citizen science field, we don't have a central database where people are populating it with data. And we have found that when volunteer data get into accessible databases, they tend to get used a lot more for ancillary purposes outside of what the original intention is. And so I think that that's a Achilles heel of our field, and that's something that a lot of people are talking about, but that gets away from what you originally asked. But yeah, it would be great if we had like a standard for the country, but since a lot of these programs developed before the feds got that organized, each state has a slightly different way of addressing it, but you see a lot of commonalities when you compare them.
I do think it's interesting, though, you're saying, I mean, with the history of water quality monitoring and citizen science is longer to some degree in comparison to some of the other environmental things that people are monitoring. So when I think about this in comparison to some of the air quality work that's done, it's almost like the water work is eons ahead in terms of really pinging in where people can fit in with their questions and with the data that, and like have actually an advocacy pathway set out ahead of time, before you're collecting data, which seems a little bit unclear in terms of a lot of other environmental monitoring strategies. Elizabeth, I see you've pinged in here with a resource. Do you want to share about this?
Oh no, I was worried you'd call me out. Well, Julie, that was absolutely fascinating and excellent rundown on the history and this tiered system. And it just reminded me of this work that we did with the Environmental Law Institute that also brought up those tiered structures. It's a resource on introduction into like what types of evidence hold up in court and what do lawyers need to consider when they're using data, because it's very different than the standards and protocols that scientists use. We may mean the same thing, but we use different words for them. So this resource was just kind of an introduction to maybe grassroots groups that want to learn a little bit more about the law and about how to make sure that the data that they're collecting will actually get used in the end. But I just wanted to offer that up. It's a free resource.
Yeah, it is a great report, and one of the things it does, and one of the things we benefit from in the water monitoring community, is there is a stipulation within the Clean Water Act and clean stream laws that require that any data of known quality be used for the state integrated reports. And so even in my state of Pennsylvania, that has a interesting relationship with aquatic citizen science, whenever they need to do an integrated report, which is every 2 years, they always do a call out for data. And so, the state, whether or not the numbers are actually used in defining whether or not a stream is meeting its designated use, it can be used for screening purposes for then the state to go in and target. Because in short, a state is looking for the best streams and they're looking for the worst streams to identify within the integrated reports to identify where they need to do mitigation. And that is something that is called out in the Clearing the Path report. I thought that was a fun report that came out last year.
Julie, just a question. Is that report, the integrated report, specific to the Chesapeake Bay area, or is that a nationwide Clean Water Act thing?
It's a nationwide Clean Water Act thing. So as the Clean Water Act is translated to the states, it requires that each state comes up with designated uses for every water body. And so when you come up with a designated use for a water body, it also comes with criteria that designated use needs to uphold. And so every 2 years, then the states need to be able to do an assessment to establish whether or not their designated streams are meeting those uses, and those are referred to as the integrated reports. There's a very interesting report that came out by the Isaac Walton League of America that called out the fact that actually there's a lot of modeling that is used for the state integrated reports, and actually only approximately 30% of our nation's waters have been monitored. So that might be something to check out. I'll find the link to that and post it in the group chat. But that is a federal requirement from the Clean Water Act that requires the states to do those integrated reports.
Cool, thank you.
So we have a lot of people on here from a lot of different places. I was interested to call out, who's the woman calling in from New Zealand? Hey, can you talk a little bit about, oh, you're on mute, sorry. I'd love to hear about what you guys have going on and what you're thinking about here in the near future.
Yeah, we were keen on creating a national database. And so we were following 2 groups pretty much. In Indiana, it seems like they have a really good community group, the Hoosier, I can't remember the name of them, it's Water Keepers. And they have a really great database and website. And I noticed that Chesapeake Bay was making a database as well. And so I just recently got approved for funding to create a national database here in New Zealand. So I'm trying to extract as much of the issues going on in the States so we can kind of get that sorted. And what else are we doing? Because we're only 4 million people, it's quite much easier to create a national strategy and get everybody kind of started sampling the same way. So in one way, we're a little bit behind, but we can kind of learn from the mistakes that have been made in other countries. So our databases are big. That's what people really want. There's been a lot of little databases and they've kind of fallen over. And as well as getting a kit that everyone can use that is low cost. And sensors are really big here, and people, they really want oxygen and nitrate sensors. And I've been researching ways of making kind of a low cost stuff using the riffle or the mayfly as well. So yeah, that's where I'm at right now, I guess. I've only started like 6 months ago. So I've been just trying to join as many webinars to figure out what people are doing overseas. And I noticed in the state, you guys have, with the US EPA and the Obama administration had put in incorporating citizen science and crowdsourcing into your actual legislation. And I thought that was pretty cool. And I thought it was something that we could push for here as well. The citizen science data is very much not looked upon very well here.
Yeah, that that potentially brings up another can of worms that someone's put in here in our chat. If we're interested in going down the road of how all these things relate to the current administration and some of the things that are on the table. If people want to go there, it's an open door.
I really don't want to go there, but I will mention that the legislation, what it does is it actually just clarifies a lot of words that federal employees have problems defining because of precedent of like, what does a volunteer, what is a volunteer, can a volunteer, you know, if they displace an employee's funding and time, can they participate? And then it also created these reporting requirements that will happen in 2 years from date of issuance. And because this is legislation and it was tacked on to the America Competes a Larger bill, it's very unlikely that it's going to get repealed. So we don't have to go there, but we can celebrate that that is safe and sound, and it just kind of clarified and allowed employees to use this method. And they can point to that legislation whenever they're like, higher ups like, what are you doing? And they're like, I'm doing this, and look, this is what this means, and this is an act in Congress. So it's positive note.
Thanks, Elizabeth.
Yeah, I mean, I would just say it's something I've seen in my Facebook feed and all that, is that a lot of people who have been not necessarily involved with things and letting things, there's a lot more engagement around issues. And a lot of that's kind of going to anger and very expressive, but there may also be, in terms of people who are looking for perhaps things that they can really build on, there might be some opportunity, there may be people looking, and it's a matter of if they're interested in how they can get involved locally on something that isn't, maybe they're pretty independent and don't have a high interest in partisan politics, but they want to, keep building their community, and they're worried about perhaps cuts to EPA and water quality monitoring. It might be a stuff around March for Scientists. It might be a place to reach people who are interested.
So I do notice that we've had a couple people join on since we started, and just before we end here, I want to make sure that everyone has a chance. We have about 15 minutes left to say who they are and to share if we have any questions or things that we want to talk about as a group here. So if you haven't had a chance to introduce yourself and you want to say who you are and you want to share something with the group, go for it. And know that you're on mute, most likely. All right. One other thing that I heard from people who were joining on that were new here was a couple people were interested and maybe potentially starting out on water monitoring projects and programs. And I was wondering a little bit, I'm trying to remember who you are, but what sort of things got you interested in this, and what are you interested in exploring? Patrick.
Hey, before we move on, if I could just touch on the last topic real quick.
Yeah, absolutely.
To Amanda, first of all, I want to make a quick plug. I actually met somebody in New Zealand not too long ago in Auckland who was starting to work with the riffle and trying to get involved with that. So if you want, we could maybe connect after that and see if that connection could happen.
Yeah, I'd love that.
Yeah, that I think would be really cool because he's actually doing workshops with kids as the citizen scientists, and they are so much more fluent in the language of Arduino and code. And to them, it's yeah, we want to measure the stream. Let's figure out how to do it. And it's so inspiring to see them do that. So I think that's really cool. And the second question I think I'd ask you actually is in New Zealand, maybe what do you think would be the process for if there's those 3 tiers of certification, 3 tiers of data use, and the top tier is okay, this is data that the government trusts to take action on. What do you think, and this could go for America as well. In America, I think it's common to have an actual lab to be certified to make that quality assurance. What do you think it would take in New Zealand for the data to be, actionable at the highest levels?
So right now I'm doing a study looking at homemade E. coli kits. So because E. coli is a really big issue here with the dairy industry, and we're trying to figure out how we could use community E. coli data to actually kind of bring about change in the dairy industry, and for the regional councils to use that data. So we were looking at Texas, who does community E. coli data, and they seem to offer kind of a yearly training course. So people who submit to the data to our database who have had this kind of 4-hour E. coli course, that data would be at least kind of a B grade. So we'd have the A grade, which would be our laboratory data, but the B grade data would be at least people who have had training in E. coli techniques. And then our C grade data would be people who are submitting data to our database who've had no training at all. But that's something that's came up in our meeting on Monday, and we were really struggling with how to kind of grade our data in the database so regional councils and the government can use it.
Can I chime in on bacteria monitoring? There are two really great states and programs that have at-home volunteer-friendly bacteria monitoring kits that they use. Wisconsin Department of Natural Resources and the Virginia Department of Environmental Quality both use what is referred to as COLA-SCAN, and it uses an at-room temperature incubation process. And because stormwater runoff is a huge issue in the states, and looking at bacteria runoff and bacteria associated with faulty septic tanks and things like that, those two states have some fantastic success stories of how volunteers have used these kits and these techniques to flag big issues. And so I can always share with Stevie some of the information on those techniques if I can't find it quickly online. But the Virginia Department of Environmental Quality, James Beckley, and then the Wisconsin Department of Natural Resources has a great at-home E. coli test.
Cool, thank you.
So we also just got a hello from Claudia, who looks like she can't speak but wants to say hello, and she's really listening, and great to hear. So hi, Claudia. Thank you for joining. Somebody did something I haven't seen on Zoom before, but you raised your hand. That was cool, like on the computer.
Yeah, I'm an
Hi, Gwen. Great, thanks.
I'm an online class.
I don't know how you did that, but somehow.
It's underneath the participants area. You can raise your hand. We do an online class at Hopkins.
Thank you.
I'm chiming in to your last question about how did you get here. So I am a filmmaker. I became interested in some of the water issues in my community after my father got sick with Parkinson's, learning that there was a very strong link between some of the toxins in our environment and some of the health issues in the community. And one of the biggest things that I wanted to answer was, so I can, I have access to the TRI, the Toxics Release Inventory. I don't know where that goes, and I'd love to see how does that match up with the monitoring in the community, and learning that some of the government, the TCEQ, that's the Texas EPA, monitoring doesn't match up with what I'm seeing in the TRI, and wanting to find out, if there was a way for us to do the monitoring in the community ourselves. So, I mean, I'm learning some of the things that I'm looking for, dioxin levels, things like that. It's, way beyond, I think, what we can do right now with citizen science. But maybe some people here on the call might be able to offer some things, maybe, going back to that, does your river have a fever? Some things that we can flag and raise to the TCEQ or to the community itself.
Great question. Does anybody want to share insight?
Well, we did look at conductivity, so we used it just to look at conductivity and temperature. So is that what you're wondering? Like, what are the things you could actually look at to see if there might be problems somewhere? Okay, yeah. So I think that I think that you could use it in that regard. And then it would tell you, if it's high conductivity levels or, do they spike at a certain time of day or a certain day of the week, okay, well, what's happening then around that time period or on that day, that's what we were thinking, when we were using it, because we knew it wasn't going to tell us exactly what was in the water and what was high, but that it would be a red flag for us, and so that then we could start to dig a little deeper. So I think that you could use it in that way, to see just what you need to dig deeper, to learn about, to investigate further.
That makes sense. Thank you, Emily.
Mm-hmm.
Patrick, were you really raising your hand earlier, or were you showing me the cool raise your hand thing?
I was totally showing off the thing, but I do have a question actually for the Riffle project. I'm sorry, I forgot your name, but for the West Virginia project, you learned a whole bunch of things, including something really interesting to me, that the watertight enclosure you could only deploy at once. And I was really curious to hear more about that, and maybe some more stories of what it was like to do this. Because I think, you know, the story of getting the story to me is really interesting.
Yeah, it was. Right. So we put our riffle in a Gatorade bottle, and we deployed them in the fall, and they all worked, and they all, we got data back from all of them, and then we did it again in the spring, and we just didn't even think, like, oh, we should put them in new Gatorade bottles, and this is kind of where I think not being a scientist hurts us. So we just used the same Gatorade bottles, and everything was working great except for the bottle leaked and corroded the sensor. So that was a bummer, but we still moved forward with the story. And actually, what I'll do now is I'll go and find the story that we did, and then I'll add that to our chat here.
Great, thank you.
Yeah, that'd be really cool.
Otto.
Yes. So we have a situation with the Santa Fe River that's, it's not exactly a living river. It doesn't flow year round, as you might imagine in New Mexico. And we have a TMDL draft for E. coli. And has anyone ever heard of doing some of the monitoring on soils, as an example, or something that we can kind of keep the data going when you don't have the water? No soil scientists out there?
I guess like the first thing that comes to mind for me is, there are lots of streams that don't flow year round. I don't know what the different monitoring strategies are for those, but I think maybe that would be a reference for you as well. Is that what are they called, Julie? Autonomal streams? Is that right? I'm pulling that in.
That's great. Yeah, and for bacteria with soil testing, I'm not as familiar with, but one of the things that the Stroud Water Research Center has played with is also those soil sensors. I know that does a lot with like measuring how damp they are. I'm not a soil scientist, so I'm not going to fake that one. But they do have some sensors that they use for soil testing, but it's not bacteria. It's more around moisture and temperature and things like that.
Yeah, and we have those, so around. But like I say, all of a sudden to try and pull up any kind of bacteria analysis, everybody goes, "Oh, it's hard." No.
All right. Well, we have just a couple minutes left. Does anyone have a question we want to close out with here? I think, Burning, we have such a good group of people. There's so many on. I think I'm afraid that people have been on mute.
Well, maybe as you're wrapping us up, Stevie, what's the best way to continue these conversations? Like, are we all on the water quality list at Public Lab, or to be able to keep these conversations going?
Yeah, so I guess for those who are interested in just OpenHour in general, this whole conversation will be archived on publiclab.org/OpenHour-archive. Thanks, Patrick, for the archive idea. But for keeping in touch and on conversations on all of these things, the Public Lab has a pretty sizable list related to water quality. And you can find it if you go onto publiclab.org/lists, and anything can be sent out there. The other thing is, if it's just, if you have a question, we also have a great question answer interface for anyone to be able to ping in on questions or answers and related to anything, and you can tag it water quality, and those following the tag would get that question. So that's publiclab.org/questions. So a couple ways to sort of, if something comes to mind later, to put it out there, or if you have an idea, post it up. But a couple good ways to keep in touch. All right. Any last couple I see there's some great resources in here. I will capture all these links and post them in with the archive. So I'll put them up there. Don't worry about saving anything. And yeah, anything else?
I just wanted to add, Stevie, and I'll send this to you as well, that in volunteer monitoring in the States, we have a couple of listservs where we have our conversations, and that is also archived on volunteermonitoring.org. So I'll send that to Stevie as well to add to the cadre of places to stay connected in for these conversations. And for our friends in New Zealand, feel free to join those as well. I'll keep you abreast of the different conversations going on, and you're free to pose questions, and people share a lot of resources there.
Cool. Thanks, Julie.
And I just want to add too that in our project, both with the water quality testing and with the air quality testing we're doing now, I mentioned we're working with experts at the university who research these topics, but also I reached out to the West Virginia DEP, which is our EPA here, and they have been very responsive to wanting to work with us more recently on the air quality project, although we also had they partnered with us to a degree on the water quality project. And so I would also encourage people to reach out to the state agencies and let them know what you're doing, because our state agency ended up going out and purchasing air sensors and testing them right alongside ours, because they know that they don't have the capacity to monitor everywhere that they really want to be monitoring or should be monitoring. And so they are also looking more toward citizen science.
All right, thank you. And thanks for everyone to take the hour and join Open Hour. It's been great. Really nice to get back to some water topics. All right. Everyone have a good day or night or wherever you are.
Thanks.
Yeah, thank you. Great to meet everybody.
Bye.
Bye.